today I'm going to be speaking about processing images on Android. So has anyone done any kind of image processing before? Okay, a few people, so maybe this is not new to you, but hopefully a lot of you will learn something from this presentation. So I didn't know I was going to get an intro, so there's more about me. But if you want to find me online, ask me any questions if you can't catch me. You can find me on Twitter @Rigaroo. If you just search that, you'll find me. And I work at a company called Over. So we're a company that makes a mobile design tool for making graphics on your phone. So we recently launched a version of our app into open beta, so it's still in testing. We only launched like last week, so help us find bugs, please. But basically, this app allows you to put graphics and fonts and a lot of images that you can put on top of, or into your app, or into your graphics that you're making. So as you can imagine, we had to deal with bitmaps. And my experience before joining this team and this project was very non-existent when dealing with bitmaps. So I had to really dive into how to use bitmaps effectively, how to apply image filters onto them, and all that kind of thing. So we had a couple of challenges, as you might expect, with this kind of app. And the first one is that you had to process multiple images. So unlike some other apps that you might be used to, with this one, you can put a lot of images into a design, and you can move them around, scale them, resize them, that kind of thing. So that was one of the challenges. We also had a lot of complex image processing. So our iOS app allows you to apply filters like sharpening, that kind of thing. So we had to do that as well. Another thing that we had to do is the ability to load up a project from storage and change these filters at a later stage. So we needed to be able to persist these sort of values in the representation of a certain filter in a file format or something like that. So that also made it quite challenging. So it wasn't like a once-off, apply this effect, and then you're done, you don't have to worry about it. But it is now going back and editing this value and changing what this image looks like. Another thing that we had that was quite interesting was that we had to deal with custom canvas sizes. So a user can change it to be a Twitter image size, or they can make it a really large Instagram size canvas or something like that. But basically, you have full control over the size of the image that you're going to produce at the end of the day. And unfortunately, we had an iOS app that already did all of this really well. So anything that we did had to work really well, and we couldn't sort of say, no, we can't do this effect or that kind of thing. So we made a couple of mistakes, as you would with these kind of apps. But the first thing that we did that was probably, looking back on it now, was like, oh yeah, that's super obvious, but it wasn't at the time, was that we were rendering the actual project size on the display instead of the display size. So if you were trying to make a project that is like an 8192 by 8192 pixel size image, we were trying to render that on the screen. And that will take up a lot of memory, and you'll almost instantly hit into an out-of-memory exception. Another mistake we made was that we were loading bitmaps up synchronously. So that's just like locking up your main thread for no particular reason, and we were doing that. So we had to change that as well. And the last thing is that we spent quite a lot of time looking into different ways to process images. So that's what the focus of this talk is going to be. But basically, we dived into a whole bunch of different ways. We learned a few issues about one certain way. We found some ways that kind of work better for us. So that's what I'm going to be going through today. So this talk is basically the talk that I wish I'd found before I started all of this. So hopefully, this will help you if you have to ever do these kind of things. Okay, so what exactly is a bitmap? So if you have a look at the actual data structure of a bitmap, it is basically just a 2D array of pixels, okay? And each pixel contains 4 channels, a RGB channel and an alpha channel. So a red, green, and blue channel and an alpha channel. So now that we know what a bitmap is, how do we go about loading one of these in our apps? So who here uses a framework to do that? Okay, a few people. So there are a couple of different options for you to load up a bitmap. So the initial way, if you go search for loading a bitmap in Android, is you'll come across an article on the Android developer documentation, and it will show you how to use this, a lot of code, bitmap factory code, to load up this bitmap. But then you might stumble upon like a little warning to say, hey, this is probably not really a good idea. So you might want to use something like Glide, or there's others called Picasso, Fresco, and there's probably a whole bunch more that I've missed out. But those libraries aim to wrap up a whole bunch of the complexities for you and do it in a bit of a more concise way than using the bitmap factory. So how do we do it with the bitmap factory? So if anyone has been on the developer documentation, this is straight from there, but basically it's quite a lot of code just to load up a bitmap and display it somewhere, or just get that bitmap object. But the problem with this is that there's a few things that it doesn't do. So it doesn't cache your bitmaps. So that is one big issue. If you keep loading up the same bitmap over and over again into memory, this can take a really long time to do. It also doesn't know how to fetch an image from a web service or from a website or something like that. If you have a URL, you still need to go and download it yourself and then store this bitmap somewhere and then load it up into memory. So that part is still left up to you. And then another part is that it doesn't handle, I mentioned caching already, so it doesn't do that either. So along comes Glide, and we're all happy. We can just load up Glide, we put in our URL, so it does all the loading from the internet, and it loads it into an image view. So the nice part about Glide is that it actually handles the scaling, the caching, and the downloading of the bitmaps onto your device. Now, if you tried to do that yourself with Bitmap Factory, you'd spend quite a lot of time banging your head against trying to get that right, and it's just really unnecessary when you've got such awesome libraries that have handled these things before. So, how many people have run into an out-of-memory exception when using bitmaps? Okay, almost the whole entire audience has run into one. So, we would probably be familiar with this kind of thing if you're trying to create a bitmap that's too large for your memory or something like that. Has anyone seen this exception where when you're trying to draw a bitmap where it says your canvas, you're trying to draw too large of a bitmap onto your canvas? Cool, a few people as well. So these are the kind of things that you would run into when you start to deal with bitmaps by yourself and start to work with them manually. So my biggest probably tip for the whole presentation is that you really need to scale down your images. So let me just give you a bit of context about how much memory one bitmap can use. So we're taking photos on our phones, and they can take really, really nice, beautiful pictures that are really, really good quality, and they're probably like 8 or so megabytes storage size. So if we look at this, or this kind of example image, if we have a height of 1920 and a width of 700, this actually ends up taking up 5.3 megabytes of storage when you've loaded it up into memory. Okay, and that you can see the maths over there, but basically it's a lot of memory, and if you're loading up quite a lot of images, or even bigger images than this, you'll quickly run out of space on your app, or in your app. So what are the thought is that you shouldn't be loading up for your views. You'll never have a view like on your device that is that large, so you should always scale it down to the size of the image view or the canvas size that you're rendering on. So in this case, you would probably want to resize it down to a smaller thing, and you can see you'd already save quite a lot of memory usage when you do that. So there's obviously a way to do it natively with Android. So there's a really nice long post on the docs to show you how to calculate a sample size and do all of that kind of logic to get a good size. But yeah, you don't have to do that. If you use Glide, like I mentioned, if you just use into a certain target, in this case, my target is an image view, Glide goes and looks at that size of the image view and then gets this, loads up the graphic into memory just for that certain size. So it's really cool. And if you don't, so for us, we didn't want to, obviously we're not loading up into like an image view or something, we're loading up onto a canvas. So we would like to specify a certain size that Glide should load up at. So we can give it the width and the height, and it will automatically load it at that size. Cool, so now we know how to load up images and what a bitmap is. How do we go about applying different effects to your app? So this is just a quick sample of the effects that you can do in our app. But basically, we went through all these different ways of working with images, and we're going to go through a couple of them today. So the first way, and probably the most naive way, is to use methods in Java or Kotlin, which is called getPixel and setPixel. You can also use glide image transformations, or the GPU image. There's also another class in Android called the color matrix that you can use. You can also use a thing called Renderscript, which we'll get into as well. You can also use OpenGL, and you can use native code to do this. So there's so many different options for you to process certain images. And there's probably a few more as well. But today we're not going to be covering OpenGL or C++, so whew, everyone can just breathe a sigh of relief for that. But yeah, we're going to get into the few that you can use and where their pros and cons are and when you should use what. So the first method. So if you Google how to apply or change a pixel value on your image, you'll probably come across this code at some point. But basically, in Android, you can take a bitmap, and you can iterate over all the pixels if you want, and you can set a pixel color. Okay? So you can just say, new bitmap, set the pixel at this position, X and Y position, and you can set it a certain color. So in this case, I just set it to blue, and it will return a completely blue bitmap, but you could do something fancier like, I don't know, sharpen it or something like that. The problem with this is that it's super, super slow, okay? So because it's running on your CPU, it really doesn't take advantage of parallel processing. So it has to go for each pixel, one by one, changing that pixel. So you can imagine this can take quite a while, especially with a really large image. So we won't go further into this method. It's really not useful for us, but it's easy to understand, okay? So give it that. If you don't want to put it in the background thread, you can wait a while for your image to process. And you can also manipulate per pixel manually. So you know exactly the values that your new graphic is going to take on. So that's pretty cool. But the big con here is that it's super slow. So if it was fast and parallel, we'd be happy, right? We could do it in Kotlin or Java, and that would be good. And like I mentioned, you also have your CPU execution. So you're not taking advantage of using your GPU and parallel processing, and no parallel execution. OK, so let's have a look at color filters. So has anyone heard of color filters? Cool, a couple people. OK, so what is a color filter exactly? So in Android, you get this class. It's not a third-party library. But this takes, it modifies the color of each pixel in your bitmap with a certain paint object that you give it. So let's have a look at how it works as an example. So this is what we call a color matrix color filter. And basically what it is it's a 4x5 matrix that you apply to each pixel, okay? So if we have a look at some cool maths, yay, maths. So you'll see there's like a really awesome calculation of exactly how it takes this array of numbers and applies it to each pixel. And it comes up with a result, and that is for each pixel on your device, on the bitmap. So if we wanted to get the same image in as what we, the same image out as what we put in, this is what we would call the identity matrix. So it's just ones all down the diagonal. And that'll basically just times everything by the correct values itself by 1, and you'll get the same image out. So you can sort of identify how that will work. So if I wanted to invert my image, so make it the complete opposite of what it is, I would obviously want to times all the pixel values by -1. So this is the example of setting up a canvas, creating the color filter with those certain -1 values, and then calling draw bitmap with a canvas and that certain paint that we have. You can also just use it on an image view. You don't have to use a canvas for this, but you can just give it an array of values that it will times each pixel by, and it will execute it. And this is super, super fast to execute. So it works really, really well. So yeah, it's just an example of what the output is. So the input image, applying the inversion, that invert matrix to the image, and we get this output image as well. So the color filters are really, really awesome to use, and you can do quite a lot with it. So you can do other things such as warmth, exposure, saturation, contrast, and grayscale, sepia. There's a whole bunch that you can do. There's also a bunch of different other color filters that you can use that I'm not going to dive into. There's a really great article written by my colleague. He dived into like what exactly each different color filter does and how it works. But you can basically like subtract, minus things, lighten up image, that kind of thing with it. So it's really, really useful and works really fast. So the pros of this kind of method is that it's easy-ish to understand. There's still like a couple of matrices that you have to make, and you have to make that matrix yourself and understand what exactly it's doing, but it's not too bad. It's super fast. So it's running on the GPU. It's not slowing down anything. And the nice part is you can write it in Kotlin or Java. Like, you don't have to dive into any sort of different language for it. And you also understand the exact effect that is being applied to each pixel because you are writing this matrix yourself and you know exactly what's happening. The big con with color filters is that you can't do every kind of effect that you might want. So if you want to do an effect like sharpening or unsharpening, or unsharp mask filter, you can't do that with color filter since it's just applying blindly a value to a new pixel. So it's not looking at any surrounding pixels or anything like that. So I stumbled upon this really interesting class, and this is a new one. It's called Image Filter View. Anyone heard of it? No one. OK, that's great. Yay, someone's going to learn something. But basically, Image Filter View is part of Constraint Layout 2. So I stumbled upon this just looking at the Constraint Layout docs. And it comes with a bunch of cool methods that you probably can't read very well. But you get methods like set contrast, set saturation, set crossfade. You can crossfade two images into one. And you also get a method called set warmth. Okay, so there's a few filter effects that you can do with this class. And this is part of the constraint layout library. So how you would just use it in your XML file is you can just set the warmth, the contrast, and the saturation yourself like that. Or you can even do in this next example, I've got actually doing it in real time with a seek bar that changes the values of those image view constraints. So the nice part about image filter view is that it wraps up all the logic for you around how exactly these kinds of things works. But if you look under the hood at what exactly it's doing, it's just using color filters. So exactly what we've applied before, but now it is in a nice sort of wrapped up version for you. So it's much easier to use. So the nice part about this is that it's super easy to understand. I just set a contrast value, and cool, my image is a bit more contrasted, whatever the word is. It's also super fast because it's just using the color filters. It's not running it on the CPU, it's running it on the GPU, so it's super fast. It's also a really nice API, so you just pass value and it sets it. And you can use Java or Kotlin. But the big con is that you can't do everything, right? So it only gives you a few sort of image effects and nothing really complex. And another con about it is that for me and for our use case was that the values are abstracted away from you, kind of. So you can see the source code and see exactly what it's doing, but if this should change at some point, your filters would be different in your app. And the fact that we needed to load them up again from storage or something, we couldn't really use this method. OK. So there's also an option if you're using Glide. So there's a really nice library that you can go have a look at on GitHub called Glide Transformations. And this basically, you can just, in your process of loading up an image, you can say, apply these certain transformations to my image, and you can give it values, and it will blur your image or whatever the other examples are. So this is also really simple to use. So if we have a look at the different pros and cons of this approach, really easy to understand, super fast sometimes. It depends on the image you're using. It's got a nice API because it's all wrapped up for you. You don't have to worry about it. It's using Java or Kotlin, whatever you want. And then the big con is that you also can't do everything, obviously. So if you have your own custom image filters or something like that, you can't do that with this library unless you create your own and maybe submit a pull request or something like that. Another big thing, which is also a thing for us, is that the values are abstracted away. So we can't tell exactly how this thing is generating the images. So it's a little bit blurred lines, and things could change at a later point that we don't want to depend on. And now you're also dependent on this third-party library, but that's probably not too much of an issue. OK, GPU image is also a very similar library. You basically just create this, this library from Cyber Agent. It's on GitHub. And you set a certain filter on this image, and you get your different image effects. So cool as well. So this is super easy to understand, fast, nice API, works in Java, Kotlin. Can't do everything again, it's dependent on the library, and the values are abstracted away from you. So very similar to the previous ones, and you're also dependent on a third party. OK, so now we get into the fun part, so Renderscript. So anyone use Renderscript? OK, a few people. So Renderscript is basically a framework for Android for computationally expensive tasks. So if you want to be doing sort of image processing or any kind of big, large data processing, you can use something like Renderscript that'll process it in parallel. So it runs your tasks on the CPU and on the GPU, dependent on what the device supports and the drivers and that kind of thing. But basically, it's really parallel because it can run your tasks on the GPU. The language, unfortunately, is not Kotlin. Damn, but it's a C99 derived language, so it's not too bad to understand. Once you start writing it, you sort of get into it. But yeah, let's get into how we can actually use it. So there's one gotcha that I feel like I should mention, because I've been told this before as well, is that there is two parts to Renderscript. So there was a compute and a graphics Renderscript. And the graphics Renderscript part has been deprecated, so hopefully compute still stays around for a while, but it's actually still widely used in a lot of image processing libraries and for a lot of apps that use it. So we'll be focusing on the compute side because graphics is deprecated. Okay, so how do you use it? So basically you create a script, so it's just a file that you create in your you create an RS folder, and you can create the name of it. So in this case, we've called it exposure.rs, and that you just create in the RS folder. So this is when we're going to get into a little bit of Renderscript, but hopefully it doesn't confuse you too much. So there's a couple of things you need to set up in the beginning of your script. So just the package name, the version of Renderscript that hasn't changed, by the way, so just 1 is always the default. And then like if it's going to work in a relaxed or full mode. So that's how precise you want it to be, and also affects how fast it'll be as well. So in this case, we're doing the exposure filter, and we've got now a method that we've defined called set brightness. Okay, so that's just going to we're going to call this when we're adjusting the seek bar on the screen. So this is pretty straightforward. You just pass in a value to set bright, and it sets the static that we have on the script. Okay, and then we've got the actual meat of this Renderscript filter. So we've got a method called exposure, and this takes in a pixel and produces out a pixel. Okay, so in this example, I'm just taking the RGB values and setting it, timesing it by the brightness, and clamping it between 0 and 2555. Okay, and we're producing out this pixel value. So when you're working in Renderscript, you've got to think of it as a per pixel basis working with it. So you're not working on the whole image itself, but you're given in a pixel, and you do some operations with that. So how do we use this? That's all we needed to write for Renderscript. So how do we use it in Java? Well, you need to create this Renderscript object, which you create by giving it a context object. And then what will happen is when you've written this code and you've built and compiled your app, you will get these script C classes that are generated for you. And that is, you can see I've got the script C underscore exposure class, and that we provide in the Renderscript object into it. And that will create the thing that we need to use in order to invoke this operation. So our filter method is going to take in a bitmap, so the original bitmap that we want to work on, and it's going to apply this filter, this exposure value to it. So there's a few things you need to set up with Renderscript, and that is you want to create this allocation object. So that is basically just an allocation, a set of memory that it's going to use in order to process your image. So once you've created this allocation for the in and the output, we would then call this script. So the first thing we would do is set the brightness value, and then we would need to call this for each exposure method. And that you pass in your input and your output allocations. And that's Renderscript working for you, and it'll go and apply and run this for each on every single pixel in this bitmap. So you don't have to run and try parallelize it yourself. This is the actual line of code that goes and does all that distributed computing for you. So pretty sort of simple from a Java Kotlin side of working with it. So once we've got that, once we've run the script, we would then maybe copy it to a bitmap or do something else with it. And then we would have this bitmap now that we can use on screen or wherever else. And then the last thing that you need to remember is to just destroy your script and your Renderscript context so that it can be freed up the memory and used somewhere else. So here's an example of the exposure filter running on a Lego image. So you can see now this is being processed with Renderscript running in and out and doing that kind of computation. So the interesting part is that there's a nice example online called Android Basic Renderscript, and they do this sort of ping-pong between the images in order to make it a really, really smooth experience for us. In this example, I haven't done that. You can see there's still a slight amount of jank between the frames, but it's still just showing the example of how to use it. Okay, so we've learned how we can apply that kind of exposure or a simple filter to it. Now let's have a look at a convolution matrix. So a convolution matrix in image processing is basically a small matrix, like you would use with linear algebra. And it is used for blurring, sharpening, embossing, edge detection, all those kind of cool things that you do with image processing. So I'm going to go through a basic example of how to use it. And once you understand this kind of concept, you can basically apply it to a whole bunch of different filters and that kind of thing. So if I wanted to sharpen an image, you can't just, to sharpen an image, you need to look at the surrounding pixels of a certain pixel, okay? Because it needs to sort of know, like an edge detection, kind of find where the edges are, sharpen those certain values, and calculate this pixel value. So we get what we call a sharpen kernel, and it's a 3x3 matrix. And this is sort of like, there's a whole bunch of like examples online on what kernels do what. But basically, for each pixel, this kernel is going to look at every single pixel surrounding it and add these pixels' values together. So if we have a look at the maths behind it, you can see we've got it's taking each value and timesing it, and then that resultant value is going to be that pixel in the middle that we're dealing with. And once you've got this sort of matrix multiplication going on and addition, you can pretty much build up any sort of image effect that you want, which is pretty cool. So how do we do this with Renderscript? So very similar code to what we had before, but basically we create the Renderscript context, and we now create we use a built-in function called script intrinsic convolve, and we say we want the 3x3 matrix, and we create this, and we provide it with the Renderscript context that we want to use. That's gone too far. Yeah. Okay, so how do we go and apply this filter? So we're going to create this float array that we're going to create in this next step is basically that kernel that we looked at previously. So it's that 3x3 matrix, and that's going to go and apply to each value of the surrounding pixels of this pixel that we're working on, and it's going to multiply it and then give us an output pixel for that. So if we look at the apply filter convolve method, let's see. Yeah, so if we have a look at this method, you'll see it's doing some similar stuff to the previous one. It's creating the allocations in and out, and then it is setting the input. So that's the input bitmap that we're working with. And then we set the coefficients. So the coefficients is that kernel that we've just created. So it's that sharpen kernel that we created in the beginning. And then we just call for each on this. So we didn't have to write any Renderscript code in order to get this mask going or this sharpening to happen. We just created this matrix, applied it, and now we're going to get a bitmap out when we're done. And then lastly, don't forget you need to just destroy it as well. So let's have a look at how this works exactly. So this is an example in our app. It's got a sharpen filter. I don't know, this is probably really, really hard to see on this one. But basically, it's sharpening the image. Just imagine in your minds that this is what's happening. But yeah, it's applying the sharpen filter to this image and producing this value out. So works really well, I promise. Okay, so there's a bunch more built-in Renderscript functions that you can use. I'm not going to go into all of them because they can get pretty complicated, but there is also one for blurring, which is pretty cool and works quite fast. There's another one called script intrinsic LUT, or a lookup table. So if you've done any kind of image processing, a lookup table is basically like a bitmap that you provide to it, and it just goes and finds the pixel value. And so you like look up a pixel value on this map, and you find the new pixel value that you should be using for that that pixel. So it's like a little map that you can use. And this way is actually quite nice to be able to share filters across devices. So if you want to have a look at some further examples, so this kind of information was really hard for me to find when I was initially Googling for it. There's a really great talk by Nicholas Roord on efficient image processing. It was done I think 6 or 7 years ago when Android first came out, but it's a really good talk about, he talks about how to build a caching pipeline as well as how to use a little bit of Renderscript as well. I also mentioned this basic Renderscript sample as well. That's a really great starting point if you wanted to get started with it. And then you can go into the Google source and actually look at like the gallery app that is on Google's AOSP. And this has got a whole bunch of Renderscript filters and some really good stuff in there. So if you want to have a look at that. So the pros with Renderscript is that it's fast. We're running it on our GPU and it's super parallel. It's highly, highly customizable. So you can write anything that you want because you are in control of the pixels and you know exactly the values that are being applied to your certain pixels. Like I mentioned, it's running on the GPU, so that's really cool. And the interaction, I think this is one of the big things for us, is that going between Java and Renderscript, or Kotlin and Renderscript, was really simple. There wasn't like a big setup process or like JNI methods or anything like that. So for us, this really, really was an easy way to get into that. The big con with this is that you kind of need to understand a new language. It can get a bit mathematical at some times, so it can get a bit difficult. And another big one is that you kind of have to manage your own memory, especially if you're doing more complicated things with doing like a single source kernel. So that's where you put like a whole bunch of Renderscript functions into one and a whole bunch more of that stuff. So then you sort of get into like the hairy grounds of managing your own memory. Another thing is that it actually packages, if you use the support library of Renderscript, it packages a native library with your app. So it can increase the size of your app a little bit, like maybe 1 or 2 megs. So it's not too bad, but that's one of the downsides of using that. So what should you use? Okay, so we've gone through a whole bunch of different ways in which you can process an image. And there's a lot of different things you can do with these different libraries. So I would say if you're not concerned with how it works, or if you just need to do like a once-off kind of operation and you're not too worried about it being able to be restored or loaded up from memory, then I would just use like an image filter view or glide transformations or the color filters. So those are pretty powerful and really do things pretty quickly. But if you want to get some more fine-grained control, you want to know exactly how much of a percentage of something was applied to a pixel, or you want to have exact control over the look of the image exactly, so you want to maybe replicate the different effects on your Android and iOS app, then you probably want to go for Renderscript or your color filters, or maybe even OpenGL, hopefully not. But yeah, you can go into that kind of operation. So I wouldn't say there's one best way to process images on Android. You just need to know which one works for me for this situation. Okay, and some final tips that I have for you if you're going to be working with a lot of bitmaps or doing a lot of image processing. The first one is that you're probably going to run into an out-of-memory exception at some point. You need to know how to deal with those, or what exactly you need to be able to debug and find out, why is my image this size when it should be a lot smaller, or what is happening exactly with my memory when I'm dealing with these bitmaps. The last one is that you need to scale it to your display. So this is super important, and this is probably the one that will avoid the out-of-memory exceptions. But you basically want to scale down any bitmap that you get onto the display size that you're going to be displaying it on, because there's no point if you're not going to be using all that memory. And then the last thing that I have is that you should use what is easiest for you. So at some point, it might make sense to just use a library, but maybe as you gain a further understanding of what things happen or how it works, you would probably want to switch to something a bit more complicated. And that is all I have for you, so thank you very much for taking the time to listen.